Okay, so here's the next question for the today's problem of the day, that is number of ways to arrive at destination. Okay, so this is also the problem basically of graph. Okay, and it's basically most important problem for the interviews. Okay, because in this a very famous algorithm will be used to solve this. Okay, so let's just understand the question. You can read the question from the Leetcode. I will just make you explain you the question from this basically example. Okay, so let's just understand what we have to do. Basically we have to find the shortest path. Okay, like from each node we have to find the shortest path. Okay, like if you see, and our destination is the last node. Okay, that is from 0 to 6, so destination is 6. So if you see, the shortest path is the, if you calculate all the possible path, that is from here, if you see 0, that is first path should be yahan, it should be from here, that is 0 to 4 and 4 to 6, that is simply 5 and 2, that is 7. So I have not told you that these 5 and 2, that is basically weight edges, that have basically weights on the edges, are the time that will simply take from one node to the next node. Okay, to reach the next node from one node. Okay, that is simply the time between the two nodes. Okay, to reach. Okay, so if you will start from 0 to 4, it will simply take 5 minutes to travel. Okay, so that's the thing. Okay, so we will first travel from, we have to go from 0 to 6. Okay, so first we will calculate from 0 to 4. This is the first part that we are going to use. So 0 to 5 is 5, 0 to 4 is 5, and then 4 to 6 is 2. Okay, so 5 plus 2 is 7. So first in a basically path that is 7. So can we find the more shortest? Let's see. So second path is this, that is directly 0 to 6, that is simply 7. Okay, that is also 7, so that's same as the previous one. Then simply we will go for next one, that is this. Okay, so 0 to 1 and 1 to 3 and 3 to 6. So 0 to 1 is 2 minutes. Okay, and then 1 to 3 is 3 minutes, that is total 5, and from 3 to 6 is 3, that is 5 plus 3 8. So here the time has increased, so this is not the shortest. Okay, we have to find the shortest path, so this will not consider as the result. Okay, so let's just move on the next part, that's simply this path. Okay, there are only two paths remaining, that is this and this. Okay, so let's just check both. So first we will check this, so that is 2 for 0 to 1 and 1 to 3 and 3 to 5 and 5 to 6, that is 0 to 1 is 2 and 1 to 3 is 3, that is 2 plus 3 5, and 3 to 5 is 1, that is 6, and 5 to 6 is 1, that is total simply get 7. Okay, so it is also coming 7. So now till now the shortest path is 7, because 3 paths is basically is coming 7. Okay, let's just check the last part, that is simply this 0 to 1, 1 to 2, and 2 to 5 and 2 to 6, that is simply 2 plus 3 5, 5 plus 1 6, and that is 7. So here also last path is also 7. So if you see the total possible path from 0 to 6, okay, that is from this 0 to n minus 1. Okay, so if you see the total nodes are also 7, so n minus 1 till n minus 1 we have to go. Okay, so that is 6. Okay, so you can say last node. So the total small, so the smallest part, smallest time is 7, that will simply take. Okay, and if you see there are total 4 paths. Okay, that is this and this, and if you see this and this, total 4 paths are possible from where we can use shortest. Basically we can have shortest time, and we can go from total 4 paths. So we don't have to return total shortest time to reach this destination. We have to return the total number of ways that can basically we can arrive at our destinations with shortest amount of time. That is, the shortest amount was 7, and total number of paths were total 4. So we have to return 4. Okay, so that's the basically question here. So okay, so and if the answer is so much large, then we have to return it modulo. Okay, so simple. So if you have studied graph, then you will have basically known the you will basically know that how to calculate the shortest path. You would simply know that Dijkstra algorithm. Okay, Dijkstra algorithm is famous for calculating the shortest path between two nodes. Okay, so simply we are going to use here Dijkstra algorithm, because if you see, weights are also positive, and in Dijkstra algorithm, weights basically positive weights are all, if positive weights are there, then we can apply Dijkstra algorithm. Okay, and for negative we can't apply. So their weights are positive, so simply we will apply Dijkstra algorithm here to find the shortest path between two nodes, and then every time we will basically check the total ways. Okay, that how many basically time we have say come the, like if we see that we will calculate the shortest path, that is simply 7, and we will simply check how many time we have seen 7 for basically and 7 is a one way. Okay, so simply more the time the 7 minutes came for multiple paths, okay, then we will simply count the number of ways the 7 minute has come, or the shortest amount of time has come to reach the our destination. So you basically understand what I want to say. Okay, so that's how we are going to do. So let's just understand what is Dijkstra algorithm. So I have written here what is Dijkstra algorithm. Okay, so Dijkstra algorithm is a way to find the shortest path from one starting point to all other point in a graph. Okay, so you can simply find from 0 to all the basically nodes the shortest path. Okay, so that's the Dijkstra algorithm. Okay, and the length could be like, edges could be simply distance, or time could be, here we have time. Okay, the edges are representing time. So it's named, basically it was named after the edge edger Dijkstra, that is basically who invented it. And we can think of it like a game to explore places, like we play games like in childhood. So we always find the shortest path to find the explore the places. Okay, or basically we have to eat the way, basically we try to use the closest one. Okay, so simply it's like the same thing. Okay, and how does it work? Okay, so it uses a priority queue. Okay, like minimum heap or maximum heap. Okay, so it uses a priority queue to always pick the closest. So we have to use the shortest time. So simply we are going to use minimum heap to store the nodes with their shortest time. Okay, we will store the nodes and with their short minimum time that we can reach there. Okay, so simply from our main destination, that is from 0. Okay, so and this will simply make sure that we will never miss the shortest path. Okay, so how basically we are going to do is, let's just take this. Okay, here, and what we are going to do is, basically we are going to take a minimum heap. Okay, that will simply store every time the shortest path for a node from 0. Okay, and we are going to take a so basically for to calculate the minimum path, minimum basically time, the algorithm is okay. Okay, but we have to basically calculate the total number of ways, okay, to reach the destination in the shortest amount of time. Okay, so for that we are going to use a path count that will simply store the number of time our time has arrived, like so we have arrived this path. Okay, so simply it will store 1. Okay, because we have arrived, we have seen that 7 minutes can take. Okay, so simply we will update 1, and then if we again see 7 minutes, then we will simply update it with 2. Then and this whole we can simply update the values. So how many time we will see 7, the shortest amount of time, we will simply return the answer. Okay, so let's just see how. So you can see I have set up all the things that we are going to use. So this is the minimum heap. I'm going to explain again. This is the minimum heap, simply that will store the nodes with the closest distance from the this. Okay, 0. Okay, and this is the path count. Basically you can say it will simply calculate the how many number of ways in which we can reach any node. Okay, so simply it is, and this is the shortest path distance from each node. Okay, that is first from 0, it is the 0 distance. Okay, and then from 0 to 0, that is from 0 to reach 0 is 0 minute. Okay, and for first it will simply store the infinity. Okay, we can't reach any node at first. Okay, so simply it will store infinity at first. Okay, so let's just check. Okay, so then it will simply check for next, that is 4. Okay, so simply it will store 4 in minimum heap. Okay, and the shortest path is 5. So simply it will store 4 comma 5. Okay, so simply, and the if you see the fourth is 0 1 2 3 4, that is simply here, and the shortest path is 5. Okay, and if you see the number of ways to reach 4 is only 1. Okay, till here, and this, so we will write at this, that is 3 4 here, that is 1. Okay, then what we will do, then we will reach this, that is 0 to 1. Okay, so 1, that will simply take 2 minutes. Okay, so simply we will write, to reach 1 it will simply take 2 minutes. Okay, and it will simply, let's just write here also in 1, that will simply have only one base. Okay, and in here, and you can simply write 2 minutes. Okay, so let's just check for next. Okay, so next here is, that is 6. Okay, so simply we will write here 6 comma 7. Okay, to reach 6, 7 minutes is taken. Okay, and we can here also write one way. Okay, only one way is there to reach, and here we can write 7. Okay, so then after completing 0, then we will simply move to next node, and we will simply calculate we will add every time the total amount of time. Okay, the previous amount was 5, and then we have to reach the 6. Okay, from 0, so we don't have to initialize every time this. Okay, so from 0 to 4 is completed. Okay, then we will move to 4, and it will simply add the 2 to the 5. Okay, so it will simply get 0 to 6, that is simply 7. So the next updated value would be simply 7, so it will simply add here, that is 2 times. Okay, so it will simply update it 2 times. Okay, we have got the 2 times. Okay, then we will simply get the, then we will move to the next, that is 0 to 1. It is okay, and then we will simply on 3. So simply it will add 2 plus 3 5, and then simply it will happen again and again. Okay, 2 plus 3 5, and then simply at this, till it doesn't reach its last point, that is simply at 6. Okay, so simply it will check every position, and then simply it will update every time this value. Okay, so simply it will be at last 4, and you can simply say this is also be updated every time, so to reach every node, and this will also be, and then at last, okay, at last we will simply return this value, that is path count n minus 1. Okay, simply we will return this, and the answer would be simply 4. So you got the basic idea how basically we are going to do. Okay, so let's just move on the code, you will understand there much more. Okay, so okay, so I have opened the Leetcode, you can see the code, and I have written the comments also. Okay, so this part will simply build adjacency list. Okay, and then we have initialized the minimum heap. Okay, for Dijkstra algorithm. Okay, and then minimum heap will store every time the smallest node first. Okay, the smallest distance node first. Okay, and this will simply the array. Okay, that will simply store the shortest time. Okay, of each node. Okay, and first we will initialize with infinity, or basically in this long max. Okay, I've told you. Okay, and this path count will simply each node. Okay, number of ways that I have shown you in the basically explanation, that it will simply store the number of ways to reach each node. Okay, then simply the shortest time, first shortest time is simply be 0. We will initialize with 0, because to source the starting point is simply distance to source is simply 0. Okay, and the ways to reach the source is also 1. Okay, only one way, and we will simply update the minimum heap also with 0 comma 0. Okay, time comma node, that is simply here, and we will loop out till the minimum heap is not empty. We have not checked every node. Okay, so simply that's the main thing here. Okay, so first we will start from current time. Okay, that is minimum heap dot top dot first. Okay, so simply we will take first time. Okay, because here you can see first here first element is time and the second is node. Okay, so we will simply first take time, and then we will take node, and then we will simply pop out the element. Okay, and if the current time, okay, the time is shortest, okay, if the current time is larger, then we will simply continue because we don't have to update. If it is shortest, and okay, we have to simply continue, and then we will simply, what we will do, we will take the node from the in the graph and then simply found a new shortest path. Okay, update shortest time and reset. Okay, basically what we will do, we will skip the iteration from this. Okay, we will, that's the continue. Okay, and we will next to move next iteration, and here what we will do, we will found every time a new shortest path and update the shortest time and reset the path count. Okay, so this is the total code. Okay, then if this current time plus road time is smaller than shortest time, okay, of neighbor node, then we will simply update the value. Okay, and we will update the path count also. Okay, and if it is not found another way with the same shortest, अगर हमने कुछ and we have found the another way, and simply we will update the path count. Okay, we will add the path count. Okay, the number. Okay, that we have basically, you know, the apps basically in this if the new, every time new we have found, then we will simply, we have to update the value, that is 1, okay, to the path count. And if we have found the same, okay, the current time and the road time, then simply we will update it with the we will add the extra number. Okay, simply update like we have seen the 7 we have found 4 times, then simply we will update the 4 at last. Okay, and then we will simply return the last element of the path count, that is simply return the answer. You can submit it. So yeah, it's this 41%, and you can see the time complexity also. So one thing is error, let's just submit it again. Okay, yeah, and you can see time of submission length exceeds limit. Okay, let's just, I will check it. So next time. Okay, so time complexity is basically big of n log n type. Okay, so okay, it's not seen here now, some problems there. Okay, so we will see next, I will see next time. Okay, so that's the question.